rating. So how to calculate the rating? I'll teach you. That's it. Okay. So we assign the rating of each factor's types or range as the relationship between, let's say, it's a landslide. It can be flood, it can be forest fire, it can be anything. Okay. And each conditioning factor's type or range. That is the ratio of total cell, and this is what I have already discussed. Now, once we do, yesterday I showed you the example of just one factor. Now we have 10 factors, 15 factors, right? So we do it for individual factor. Okay? Let's say you have the landslide locations, right? Then you have the different conditioning parameters, altitude, slope, aspect, curvature. Then you have stream power index, topographic wetness index, and land cover, okay, distance from fault, and so on, right? So you do the analysis for each factor. Are you ready me? Okay? Now, once you do that, the next step would be, okay, now let me just teach you again. So now, to this point, actually all are clear. You know that how we came up with this frequency ratio value? So, greater than 1 equals to or greater than 1 means there is a strong relationship between the inventory and that particular class. Below 1 means it is you do not have much. Alright? And you wouldn't have negative values, right? Can you have negative values? Okay, now once you obtain these values, so for class 1, the frequency ratio values came at 1.25, right? Because 40% divided by 32%, you get about 1.25. Okay? So now what you do the next step is you go and reclassify this input data based on the value that you have obtained from the frequency ratio. Okay? So that means whatever pixel values that you have here, class 1 reclassified or reassigned to the value of 1.25. But because we are doing the raster-based analysis, obviously we have to do integer. Okay? That means 125 you just multiplied by 100, so 125, 1.25 multiplied by 100, you just make it 125. Doesn't matter, regardless whether you are doing from 0 to 1 or 0 to 100, finally you still can normalize, isn't it? The final result you still can divide by 100, right? But because raster-based assessment that we're going to do, it has to be integer value. You don't understand me? Say yes? Okay? So, for class 1, you multiplied by 1.25, multiplied by 100. Not multiply, assign 1.25, multiplied by 100. Class 2, 1. Class 3, 79. 0.79, 79. Okay? Now you are having the reclassified map or input data for all the variables or condition parameters. Okay? So what you do, once you have that, you just go and you calculate actually the landslide susceptibility index is the summation of the frequency ratio values of all the input conditioning, the reclassified based on the frequency ratio value of the conditioning factors. It's easy. But I am telling you easy because we have already found out it's easy. Otherwise, it's very hard. It took us about 1.5 years to establish this. But that was in 2000. And you will see till today, there's still a lot of papers being published using this across different domains. Okay? Are you ready me? So I'll give you some data and then you can do the tutorial. Well, it's boring for me actually to teach one by one. What I can do is that I can give you some tutorial kind of material. You can just follow the step by step and I'll do that. Okay? Understand? So this is clear?
सर जो यहाँ पर तो दिखाई दे रहा है क्लास 1, क्लास 2, क्लास 3, बट अगर हम फॉर एग्जांपल स्लोप ले हाँ स्लोप में कि यहाँ पर ऐसे कि इतना पिक्सेल्स करके हमने पॉपुलेशन एक्सेप्ट कर लिया तो मैप में कैसे लिखा है
तो मैं बता yesterday I said that you reclassify first, right? The slope, everything I said that you reclassified as a quantile and make into 10 classes. Did I tell you? especially for the continuous data. Slope is a continuous, altitude is continuous, because you do not know what should be the category that you would like to classify. So just to give the benefit of doubt, statistically, just we reclassify as quantile 10 classes. Quantile means mostly equal area classes. That means each class you are dividing into 10 equal area classes. Okay? But for categorical data, it is already categorized. Let's say aspect is already 9 classes, right? Or curvature is already 3 classes, okay? Or if you have land use land cover, already the designated classes are there. Soil, number of classes. Ethology, number of classes. So these are called categorical data, these are called continuous data, okay? You must understand this because in logistic regression, this plays a very important role when you feed in into the logistic regression model. Because logistic regression model takes the next step. It also gives you the weight factor for individual variable plus there is a constant value it will give you to derive the equation, the logistic regression equation. Okay, so are you all with me? Okay, any other question you have? Ask if you have a question. Now, this is the example. Now this equation already understand. Okay. Now this is the one example. Let's say you have how many classes? I said 10 classes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Values forget about it because once you export as a Excel file, it will come as actually 1 to 10. The feature ID will come as 1 to 10. That's a raster. Okay. Now number of pixels for individually. You see almost equal area as I told you. So almost similar values, very close to each other. Then number of percentage of pixel, you can see almost close to 10%. Okay? Pixels in domain, this is the landslide. How many pixels that actually occur? This is another case study, okay? I'm just showing you one of my paper. So there are about 233 landslide locations here. And they are all being distributed among all. You can see between the range of, this is altitude I think, between the range of 253 to 314 range of altitude, maximum number of landslides has happened. Okay? Then you calculate the percentage of pixel. Then just this divided by this, you get actually the frequency ratio. So you can see here clearly this class shows frequency ratio value 4. That means it is statistically too much significant. Okay? The relationship. And I am telling you this model you can apply in any other application as well. Okay? When you are trying to create this kind of map. Okay? Now, the data that I am going to give you, this is what actually the result is going to be. Slope, I told you 10 classes. Number of landslide, this is the Jingu data. Yesterday the Korea data I was mentioning. We had about 1,800 landslide, right? So, this is the number of classes, number of landslides. So if you sum it up, it will be 1,800 something. Okay, number of pixels in domain, then number of percentage of pixel in domain, then latitude ratio. You can say latitude ratio, you can say also frequency ratio. Okay. Now what is the next step? You take the slope map, okay, which has this 10 class, then reclassify the map based on this. Okay, that means this value would be computed as 7. This value would be computed as 29. Third one is 64. Fourth one is 94, 111, 144, and so on. Okay? Do it for all. Okay? I have also developed the tools to automatize the process, which is being used by the Brunei government, Malaysian government. You know, because finally you have come. Okay. So, alright? Huh? So, aspect, curvature, you do it GWI, SPI, distance from lineament. Distance from lineament, I also told you, we do not know what should be the optimized distance, so we reclassify into 10 quantile classes. Wherever you think that you are not sure, it's better to just reclassify as, don't put data, reclassify as 10 quantile classes. Okay? Then Then you have geology, land use, you got diameter, you got type, everything. You calculate the frequency ratio. Okay? Solid material, solid texture, blah blah blah. Finally, in the raster-based assessment, go to the raster calculator. All the reclassified conditioning factor using the frequency ratio value, you just R. That means reclassified frequency ratio plus reclassified frequency ratio aspect plus reclassified frequency ratio of curvature. Okay? So this is what actually, now in here you can see they are already classified corresponding pixels. Right? Finally, you get a map like this. That's why you see the paper. But you won't get like this classified map, okay? So what you get a wide range of values in your raster output. Again, you follow the same classification scheme. Go to reclassification, because now this, because see, when you give, let's say, a map or output, which are just got the values, so authorities who are interested to know, to take decision, they wouldn't know what is this values. You have to know some statistical values, pixel values. I am not interested in all that. Tell me exactly which one is the very highly susceptible. That's what I would like to know. Which one is non-susceptible? Because I must focus on the area. That's what from implementation point of view, right? So then what you do, you take the, this is one step after, okay, I mean before one step. So the output value, once you sum it up, you go reclassify, quantile, first step, reclassify, quantile, 10 classes. But you don't reclassify yet, don't save the output yet. So now you have 10 classes. Then what I would do, I would take, pay attention. So what I would take, I would do, so you have one, okay, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus. Right? Correct or not? So let's say the output before this, that means how do you get this reclassified? When you say low, medium, moderate and all that, there is some science behind it. You can't just anything that you do. Many students that don't know. Okay? What I would do, I would put the last 10% as, that means the last 10% is very high. Okay? Next 10% I would put high. Next 20% I would put moderate. Next 20% I put low. Next 40% I put heavy. Okay? So most of the output and maps, the results that you see in the papers or any kind of maps that you see, they wouldn't give you actually wide range of values because this is useless from implementation point of view. That is how they reclassify the maps. Not they, I mean some people they use standard deviation, some people, but I use all last 25 years I have been using this classification. All my papers, you will find this classification. Okay? Finally, you get like this. But in this case, we have taken 4 classes. So depending on, because sometimes what happens, depending on the area, the authority says, or public work department will say, no, it is too confusing, having too many classes. We just want one very high, medium, low. That's why. We don't want low and very low. Okay? It's very confusing for them. So what do? You just mix 40%, so 60% is already low. What? The 10% and the 10%, because that you are taking with conservative values. Because because you are predicting something, right, in the future, and if you over predict, let's say now in this case, there is also choice for you. If you want, you can also take. Want to change the color? Okay. Let's say if you take the whole thing as very high. Okay, that means you are over predicting. Okay, so the areas we are not supposed to be also susceptible. We are also assigning that as very high. So if the landslide doesn't happen, you don't say you don't know anything, right? Right? Good. So interesting. This is very interesting. This is my last year again. हाँ.
सर ये रीक्लासिफिकेशन कब करें? फॉर एग्जांपल कि हम सॉइल मैप में हैं और वो मेरा .ssp फॉर्मेट में है, तो उसको रास्टर
कोई भी फॉर्मेट हो, फाइनली यू हैव टू कन्वर्ट इनटू रास्टर. All the analysis has to be raster. I have already told you yesterday. Every input data should be converted into raster. They should have the same pixel size. Otherwise, you won't be able to do the raster calculator. Just now I said that summing up everything. You can't do actually a proper. Your calculation of the frequency ratio values will be wrong. Okay? So everything should have the same. And also, your input data, the landslide location also will have the same cell size. 10 meter means all 10. That means 1 pixel is representing the landslide. Otherwise, how do you calculate the frequency ratio values? Think about statistically, right? Huh? Okay? Any other questions? So then, in this map, you see what I have done? I have just wrapped it or overlay the training landslide data and validation landslide data. That means training and testing data I am just overlaying to see visually does it make sense. And I am 100% sure it will make sense. Okay? Now, next, how to do the validation. Okay? Now that we have already a beautiful susceptibility map, okay? Now how to validate the map. Remember, the input data we had split actually into two types. One is training, another one is testing, 70-30, okay? But you have more data that you can have 50-50 also, okay? And also another way I said, temporarily also you can split if you have the data in a complete way. That means temporarily you know that 1970s till now, and every year you know that this data belongs to this year, this data belongs to this year. Very unlikely. Okay? Now, how to do validation? I think you all know. Statistically, when you want to validate something, there are two ways that you can do. One is called area under the curve. Another one is called receiver operating characteristics. Very simple way they calculate. So ROC is nothing but it's a true positive and true positive and false positive. Okay, that means what it does, it takes the graph x-axis is the false positive rate and the y-axis is the true positive rate. And you can see the values are varying between 0 to 100, right? Because ultimately we are going to calculate the percentage, right? So the area that comes under this, that would be calculated actually the accuracy. So some people get confused. So ROC and AUC are almost similar way. Okay. But there are so many ways now statistically actually to calculate also. Okay. So area under the curve, again there is a curve here, let's say y equal to x. So whatever area comes, the positive aspect, positive side from x-axis, this area is considered actually the area under the curve. So in every figures that in the validation part, you see AUC, ROC, AUROC, and so on. Okay? In Excel also you can do it. There are so many softwares you can do it. Python also you can do it. R also you can do it. You just search. In ChatGPT also you can search. It will give you the Python code also. That's not a code. Okay? Your life has become very easy actually. Yeah? Yeah, you have someone from Australia coming and teaching you. Then you have all the tools at your fingertip. You don't have to discover too many things on your own. You don't have to struggle. Right? Okay. Finally you get the graphs like this. Now, how do you do actually the area under the curve? Basically, you use your output map against the text data that you have left. That at 30%, because that is the true indicator of the success rate, a prediction rate. So there are two graphs that you can produce here. One you can produce as a success rate, another one is prediction rate. Success rate would be when you use the training data versus actually your output. So what is the success? That means this is the data that you have used to build the model. Now what is the success rate? Okay? But the prediction rate is the data that you have not used it. Now you are actually using against the output, the graph that you get, that is called the prediction rate. Okay? Right? But remember that you are just using the test data, not all 100%. Okay? So now you see there are many models here we used. Likelihood ratio or frequency ratio give about 84%, weight of evidence gives about 69%, logistic regression gives about 77%, ANN gives about 83%. So in this case study, a simple yet very powerful method like frequency ratio model even outplay the ANN-based model. Don't underestimate the power of frequency ratio model. Okay? Got it? Now, another one also
Consider maximum in consider model.
No, in this case. So that's why I said there is no, I mean, if you know how to do the modeling of different types of models, you should try it. Because you wouldn't know what model gives you the best accuracy. Okay? Then another aspect of validation is also field survey. That means randomly you pick up some areas where you do not have a good distribution of the sample data, the training sample data. Go to the field and then check. There might be some new landslide that has happened. Maybe the data is of 2 years old. Now in the last 2 years maybe some new landslide would have happened. So that is called field validation. Okay? So you see here we zoom out, we zoom in actually to an area, then we went to the field, then we check. Okay, there is a new landslide that has happened. So that reaffirm saying that this area we have correctly predicted. Okay? For all, some areas you can do it. But you see, the prediction map looks so beautiful. Just follow the shape of this slope. Okay? That is another example of landslide probability or susceptibility map using software pattern. Similarly, it's just that this is a different model. This is another method. It's a data driven based method using the support vector machine. Okay? Anyway, remember one thing. All predictions are between 0 and 1. So it's a probability. 1 is very likely, 0 is not likely. Yes.
Sir, suppose success rate comes out to be below expected value. So how we can just improve our?
That's a good question.
Eliminate the points.
No. Not don't eliminate the point. I did mention at the beginning the preparation of the input data. Right? So that's why when you take, let's say, the inventory, because everything depends on the inventory that you know, right? So when you take the inventory and let's say the inventory is being prepared by an agency, but not sure, 100% sure, you can't actually trust 100% that this data is totally correct. Some human being has done, they would have collected the data from different sources. So now I gave you an example. There is, let's say, about 100 landslides in your database. It is showing has occurred below 5 degrees slope. Okay? For me, logically, it doesn't make sense. The definition of landslide says it is a gravitational force that actually pulls when the soil saturates. Right? And 5 degree, what? 5 degrees like this. How the landslide will happen? That means maybe there is a landslide has happened, but they have picked up actually your point at the toe end of the landslide, not actually at the failure zone. Did I tell you? So you have to check. Good. Now that actually check that, oh, okay, the result is not coming good. I mean, at least 70-80% should come. If it is, especially the success rate, then you go back and check. Logical is very important. Logically is very important. It's not about just bringing the data in, doing the analysis in the computer. You have to apply in your mind.
So should I change the point manually after?
How? Have you done the field verification? I would rather eliminate that. The point. If it is very dubious point, I am not convinced that this location doesn't make sense to me. I would rather, or maybe the location of the landslide is in a river. Because you do not know how they have captured the data spatially, what scale. Now it has actually, so now you are predicting actually a very low land area, close to the bank of the river, also very highly susceptible. Right? It's always dependent on the data. Make sure your data, spend more time actually on the database, producing your database. Don't rush into the market. Each individual data should make sense. And when you write a paper, you've got to explain the statistical descriptive analysis of your data. You must explain. Okay. So here you see I put here success rate, prediction rate. Nice. Okay? All of you are with me? Okay, good. There is another case study here. Okay, there is so many more, thousands of papers you can find in this domain. Okay. Frequency ratio model, theoretical aspects, we are done. And I think it's a very nice, simple, robust, yet very powerful model actually to do some prediction. Okay? If you do not have any questions, we'll move to the next model, that is called logistic regression model. Any question? Clear? If I give you actually the input data, you can produce a susceptibility map for me. Sure. Like you're confident though. It's easy. It's easy. Okay. Now, logistic regression model. Similar, same input. All inputs are the same. Now, here we have to understand, most important aspect is that which parameters are, which conditioning parameters are continuous and which conditioning parameters are categorical. Because the logistic regression model, when you want to run, basically it will ask you to give specific categorical data, continuous. Okay? Understand? This is how. Again, here, in the previous case also, known landslide we took as 1, right? And the rest of the cells we took as 0, isn't it? Right? 1800 landslide when we had, basically what? We assigned is 1. Each landslide pixel is known as 1. And the rest actually of the study area is 0, right? The same thing also here. Now, in this case, in the case of frequency ratio, it's a probabilistic based model. That's why you are doing the analysis individually with respect to the dependent variable, which is the inventory. But it doesn't actually analyze between them. Did it? Like, no, right? So logistic regression does actually also analyze the relationship between the variables as well. Okay? And frequency ratio model didn't give you the weightage of individual variable, because we assume each variable contributed equally. That is why we took the summation of all the variables. Finally, we produce the susceptibility map. In the logistic regression, it goes to the next step. Also, it calculates the weightage of individual variable, especially for the continuous data. Okay? So now we'll see.
Sir,
Now,
I have a question that for the sir. I have the last 30 years of flood data, like government published data, that of which like Mojas, small administrative unit have totally flooded or partially flooded, and which percent of crop has been damaged, etc. Then on the basis of that, can I put the points, like training points?
Yeah. But but in machine learning based model, you need to have your training data, equal number of flooded data and equal number of non-flooded data, so that you are not biased.
50-50.
Yeah.
It would be better.
Yeah. That means 1 you are taking the flooded data, 0 also you take non-flooded data. Let's say if you are taking 100,000 samples of the flooded data, you take 100,000 samples of non-flooded data.
If I do 70-30 then, like 70% total?
No, you don't understand. That means 70-30 is actually that you are splitting the inventory. But when you do the training, especially in the machine learning based model, you got to also make sure that that is flooded data and the non-flooded data. Balancing, the data balancing has to be done. Because you would like to train the machine as much as you could. Machine doesn't know. Okay. For example, you must, let's say, river. You have to tell that actually the river is not a flooded place. The river is supposed to be having water, natural water all the time. So it should be 0. Okay. Sea, ocean, that is also 0. Right? Like that. Okay. Now, as I mentioned here, you see you have the binary value, the 0 and 1, that is the landslide here. Continuous value, that is slope, lineaments, distance from the distance, all the distance, everything. Categorical value, aspect, coverage, duration. Are you getting me what is a categorical value? Categorical is also called as in statistics as a discrete value. Are you all getting me?
Yes.
Okay. Now, I have put actually some of the screenshots that how to calculate this in SPSS. Can we install the SPSS? At least they should learn and produce 2 prediction maps. One is frequency ratio. Frequency ratio they don't have to do anything because already we have that. Or are you bringing your own laptop?
Yes.
That's better because we cannot actually install some of the. I want to mention. So you install yourself and come because we can't install on the institute. Okay. ArcGIS also if you can install it will be better. Okay. So you are learning that, but ArcGIS you should do that. जुगाड़ करने के लिए तो माने ठीक है तो उसको कर लो और SPSS also bring your own laptop because then what happens is that if you cannot finish whatever stage then you can go back, you can always continue at home and you know it is exciting because when you are doing something and you would like to achieve that predictive map how should it look like, you know. So bring your own laptop, install actually the SPSS student version and they have that trial version. Okay? At least we will run through. At least you want to learn something. Okay? Good. So what we do here, I mean there are many softwares you can use. You can use SPSS, but for me SPSS I like because it's a very powerful mathematical software used by the mathematicians, statisticians. Okay? Use also V.G.K, which is a free software. And can also use Python. You can also use R. Depends. But let's use this. Okay. So the thing is that because it's a statistical software, it doesn't actually take the image data as input. And remember, all your input data actually are image data. All they are raster data, grid data, cell data, right? So they are image data. Correct? So it doesn't actually take the raster data. So what you need to do, first you export all your input data to ASCII data. So in the GIS or any of the GIS software that you're using, you can export the data to ASCII file. Okay? That is called ASCII raster. Okay? Now, once you export it, basically you can open that actually notepad. ASCII data, right? You can open in the notepad. Open that and delete actually all the header information, right? Because the image data has the header information, right? Number of rows, number of columns, and cell size, and all those things. You don't need, because SPSS cannot read that. You just need actually the raw ASCII. Remove that. After removing, you see here in our view I'm showing here. Go export, select actually put data ASCII register, and then this is you delete. Okay, you see the rest of the values are there. You just delete and then save. What do you do? Go to the SPSS, then go to the data, okay, and then you open the data that actually you have created. Okay, now you have maybe 10, 15 or 20 variables, right? You open data, right? Then we'll do that step by step. I'm just telling you that, later actually we will do that. Then you select the delimited, then you say no, and then go to the next page. Then you just follow all ASCII data, convert ASCII data into SPSS. Now the ASCII data you are importing to the SPSS, and you save as a SPSS data, so that the software can run the model. That means the data is ready actually to be understood by the software. Okay? Then you delete all files. Then there is one tool in the data section, go merge files, because ultimately we just need one file. Okay? Data, go to the merge files, then you select all data set here. See here? Right? And then you go to the regression tool. Go to the analysis, go to the regression. Then here you basically select which is dependent variable, which is independent variable. Okay? Right? Dependent variable is the landslide. All others actually consider as independent variable. Again in the independent variable, then you select which one was, which one is categorical and just select which one is categorical. Right? Just it's a step, just go and select which one is categorical. So that now the model understand, okay, this is the dependent variable, these are independent variables, and these are discrete data, these are continuous data. Simple. Run the model. Okay, this is what the equations they use. We will understand more. We will understand more later on. So then, finally you get actually the equation something like this. See, here for the continuous data, it comes with a weightage value. Right? For the slope, you see, it gives a weightage value. TWI, continuous data, gives a weightage value. So TWI is negatively correlated. That means it didn't contribute much actually to your final predictive map. Final prediction. Okay? SPI, negatively correlated. Lineament, negatively correlated. Aspect, because it's categorical, so obviously you don't have to, it doesn't give you the weightage, but it gives you the logistic regression coefficients for individual classes of the category. Let's say aspect, you have 9 classes, right? So each class, like in frequency ratio value, we got the value and then we reclassify, right? It gives you actually the value for each of the classes, each of the category. Okay? Curvature, geology, land use, diameter, type, data, and finally it gives you actually a constant value. Okay? So for every data when you do the analysis, you will get actually different values, depending on the data type, depending on the relationship that exists between the inventory and also the different type of variables. Okay? In the paper you will see actually quite a lot in the logistic regression. This is how they come up with. Okay? See, I'm just showing you in a tabular format for aspect. See, for individually I told you, it gives you the coefficient value. For each class, see, flat area negative, yeah, well understood. Isn't it? Flat area you can't expect actually landslide unless the land subsidies. Okay? So, and southeast is actually very, which one is the highest actually? South face, slope facing the southern direction. Basically they are more. Okay. Curvature, you see, you get the value geology, you get the value land use, you get the values. Okay. Soil texture, you get the value. Okay. Soil texture, there are so many, right? Then you get getting the coefficient. Now, what you need to do? Okay. Land use, again you are getting the coefficient value. Timber diameter, again your timber type, timber age, timber density, soil thickness, soil material, soil density, they are all input data, right? Discrete input data. So they all provide you the logistic coefficient values. Then what you do, like in frequency ratio, take your discrete data, the input discrete data, reclassify the classes, individual classes or categories based on the coefficient value that you have obtained. Okay, but again you have to make it integer because everything we have to do it in raster based analysis. Those who are late, I don't know whether you can be able to follow or not. Okay, you can check with your friends. Okay, are you getting me? What is the process? In the GIS, all your input data export to ASCII raster. In the ASCII raster, individual files open it actually in the notepad, delete actually the header definition, right? Save it. Now go to the spaces. Now import that ASCII raster data. Save individually those. Then finally merge all the data. Once individually they are all back, merge all the data, create just one file. So when you merge the data, obviously it would ask you what is the dependent variable and what are independent variable. In the dependent variable, select actually your inventory, okay, which has only 0 and 1. And remember, all should have same pixel size, same raster size, pixel size, and the area, I mean the boundary of your study area has to be the same. Right or not? Now go actually to the independent variable. In the independent variable, then select the discrete data. Okay, it's just steps, just follow. Done. Run the model. It should give you a report. In the report, it gives you actually the coefficient values for all the discrete data, and also it will give you the coefficient of the weightage of the each continuous data. And also the constant value, that is actually where you derive that equation, right, in the raster. Okay, done. Once you do that, okay, I'm teaching you how to do the reclassification. Right, here you see, take the input data, go here, then based on the coefficient value here, you just reclassify. But obviously here is, this is for geology, you go back to geology. See here, we have how many? Like 1, 2, 3, 4, because the last one is 0. Okay, so 0 means 0, you have to actually remove, don't have to, just put 0. Okay, so here minus 5.3, minus 0.5.2, see here, right? So the input data now here is what? Geology. Then open the attribute or reclassify. You can do any of the GIS. You can reclassify based on this value, right? But obviously you have to multiply by 1000 because you want to make. Don't worry about what is the digits coming. But normally it would be 3 multiplied by 1000. Okay. All right. Finally, you get the landslide. So, and how do you actually calculate this? Open the raster calculator, right? And then the equation I showed you, you just do that equation, right? So all the input data are there. What is the coefficients are there? Then you have the constant value also there. Automatically it will provide you this kind of output, predictive output. Then again, to reclassify into 5 classes, how? What to do? Quantile classes. Then I said 10, There are different types of logistic regression models there. Remember, logistic regression, although the name suggests the regression, but it doesn't do any regression analysis. Okay? Ultimately, what it does, it actually predicts 0 or 1. Okay? Whether a student is going to pass or fail, you can predict. Okay, the one that you see, the math situation, the prediction, right? In the IPL, tomorrow there is one, right? Okay? The prediction comes also from that. Now the weightage is what? Only high weightage. Okay? And the how high weightage comes out based on its previous performances, right? Now you think statistically.
There is a inventory.
Yeah. Target is let's say 300. Okay? Then the ability of the player to turn it around. Okay? Rishabh Pant, ability is very high. So obviously, as long as he's there, the predictive accuracy would be, I mean, what you call, the prediction of India to win is high. The moment he goes, you see that drop. Like 20 years ago, Sachin outs, maybe 90% to drop about 10%. Right? 20-25 years ago. During my time, if Sachin Tendulkar is out, we used to off the team. Don't waste time. And rightly so. After half an hour, all of them would have already marched back to pavilion. Okay, but not the current Indian. So that's how. Whether you are predicting a student will pass or fail, whether any kind of prediction. Now, make sense? So that's why I mentioned you. Regardless, whatever domain that you are working on, these models are highly valuable. Okay? What you need basically is to predict something. So predicting something means it's a probability estimation of 0 and 1. Okay? And then you have some dependent variables and you have, one dependent variable and then many independent variables. Not knowing that how do they going to behave, what is the relationship between them, right? So these models actually extract those features, right, to establish the mathematical formulas. Actually, I thought of quite nicely because we follow the schedule. What was the lecture space? Multivariate logistic regression model to landslide, forest fire, flood susceptibility mapping, and blah blah blah.